Hello students, today we're going to be talking about inverse variation. Now the purpose of this lesson is that at the end of it you should be able to solve inverse variation problems. Now yesterday or last time we worked on direct variation, where if two things are being compared and one increases, the other one also increases, where the change in one also affects the change in the other in the same exact way. So the example we used last time is the more hours you work, the more your paycheck will be. And in that instance, that was a direct variation, because the more hours, the number of hours that increased, the higher your paycheck went. Now inverse operation is the complete opposite. It's when two items being compared have an opposite effect on one another. For example, if you work more hours, if the number of hours you work increases, and that results in less money in your paycheck, that's an inverse operation. That means you worked more hours, but your paycheck went down. Now the formula we use for inverse variation is y equals k divided by x, where k is your constant of variation. Now, what we're going to do is we're going to take a look at three quick graphs, and I want you to determine whether or not each of them is direct or inverse variation. So this would be a good time for you to pause, look at each graph, and see if you can figure it out. Hopefully you've paused the screen. And let's take a look at number one. So let's track the x values and see what happens to the y values. So as the x values increase, our y value is also changing. It's also increasing, but in a negative fashion. If you look at number 2, as x increases, so does our y value, but it increases in a positive direction. So in this instance, both of these could be considered direct variation. Okay, and those are usually determined by a linear graph or a line graph. In number 3, we're going to take a look at the following. As x gets larger, our y value continues to decrease or go down. So this would be called an inverse variation. So let's take a look at a couple examples. For the most part, they're going to tell you when things vary directly or inversely. If that's the instance, we just need to be able to use the appropriate formula. Now remember, direct variation uses the form y equals kx. Inverse variation uses the formula y equals k divided by x. Now, these are two really important things to keep in mind, because as we work through the problems, you'll just need to reference each equation accordingly. So example 1 says, suppose y varies inversely with x. Write an equation for the inverse variation. Well, if that's the case, we can easily just use the formula from above. And once we have that, drag it right down here. Let's change the color really quick. And we know what y is, we know what x is. Therefore, we could just substitute those values in. We get 6 equals k divided by 3, because our 3 is the same as our x value, or we're substituting that in for our x value. And there's our formula. This would be a good time for you to figure out that k is equal to 18. Therefore, that's our constant of variation. Number 2 works the same way as inverse variation, where we have step 1, find k. Step 2, find the missing. So if that's the case, and we know it's inverse variation, then we could use the same formula we mentioned above. notice how we're constantly reusing the formulas based on what they tell us. Now, if y is equal to kx, then couldn't we substitute these values in and say y, or I'm sorry, 12 equals k divided by 6? And if that's the case, in order for us to get rid of divide 6, we'd have to multiply by 6 to both sides, leaving us with k equals 72. So now that we know what our constant of variation would be, we could use that value to help us figure out the second portion, which is to find y. So we know that y equals k divided by x, and well, we know what k is. K is 72. So k equals 72 divided by 9. And we just need to solve for k. And because all we have to do is simplify, we can figure that y is equal to 8. Pretty simple, right? So let's try example 3. It says, given the table below, does the data represent an inverse variation? Now, remember, in order for us to find the inverse variation, we're going to need to use the formula. So y equals kx, and we're going to need to do that for each of these pieces. Now, in order to do that, we're going to take these values, since we know x and y's but no k, and we're going to say k equals xy. And we're going to do that for each line. So k equals 4 times 15 for the first one, which turns out to be 60. For the second line, k equals 6 times 10 for x and y, and that's also 60. Good sign. And we're going to do that for the last line, k equals 10 times 6, which is also 60. Now, because all of these k values are exactly the same, then we can say this table is an inverse variation. Now let's look at example 4. It says, explain whether each situation represents a direct or inverse variation. You buy some chicken for $1.79 per pound. So all we need to do is think about whether or not this is direct or inverse. Whether or not if the number of pounds that we buy also increases the amount that we pay, or if it's the complete opposite. The more pounds we buy, the less we pay. Now, if you think about it, if we bought 1 pound of chicken, that's $1.79. But if we bought 2 pounds of chicken, that means the number of pounds we bought increases. That means we just paid $3.58 per pound. So the value of how much we pay is also going up. Therefore, this is a direct variation. Now, it's your turn. Try to do problems 1 and 2 and post your answers to Edmodo. First person will start it. Everyone else will just reply to that thread. That's all for now. Thanks for listening.